This project aims at the Ethernet in cyber-physical systems. It is funded by NSF and the principal investigator is Professor Liang Cheng. Ethernet is widely used in the industrial control systems, avionic systems and vehicular networks. With the development of Industry 4.0 and 5G, more and more sensors and actuators are added to those networks. The delay will increase when there are more flows in the network. However, there are time-critical flows existing in networks which require a guaranteed maximum end-to-end delay. The aim of our project is to establish a systematic way to design, characterize and refine the network infrastructure in CPS to meet the requirements of time-critical flows. Moreover, we want to develop both software and hardware for the outer research groups. Developing a method to solve non-feed-forward networks, in contrast to state-of-the-art methods targeting feed-forward networks, is the aim of our project as well. In the first part of the video, we will talk about the network calculus. Network calculus is a theory used to calculate the maximum end-to-end delay of the flow and the buffer size of the switch. The red line in the figure is the arrival curve and the blue line in the figure is the service curve. The arrival curve is the envelope of the cumulative curve of the sender. The service curve is the minimum performance which is guaranteed by the switch. The maximum end-to-end delay is the maximum horizontal gap between two lines. In the second part, we will introduce the topology of the testbed. In this experiment, we use a very simple four-tandem network topology which is shown in the figure. The network topology can be modified easily by changing the connection between switches and the number of switches. In the photo of the testbed, cables are connected if they have the same color of label. Ethernet port with orange label is connected to the receiver and the black cable with blue label is connected to the sender 1. In the third step, we conduct the experiment using the testbed. We get the arrival curve and the service curve of the network. Two animations are used to show how to get the arrival curve and the service curve. Here is an animation of searching the arrival curve. The red line is the cumulative curve of the packets. Blue and cyan lines are the two boundaries of the binary search. In the end, the two boundaries will converge to one line which is the arrival curve we want. Here is the animation of calculating the service curve. The blue line is the cumulative curve of the sender and the cyan line is the cumulative curve of the receiver. Red and yellow lines are two boundaries of the binary search. After getting the service curve, we use a specific example to show the definition of the service curve. The x value of point B is equal to D. There exists a value s that a prime D greater or equal to AD minus s plus beta s which is shown in the figure. In the last step, we will calculate the maximum bound of end-to-end delay based on the parameters we got from previous steps. We use a toolbox called DiscoDNC to do the calculation. It shows the result using TFA and SFA. SFA gives a much tighter bound than TFA which is approximately 0.37 seconds. The bound is larger than 0.18 seconds which was gotten from the measurement.